Okay, let's do question number 11. The equation of a curve, and there is the curve, find the coordinate of stationary points. Now, if you see stationary points, you think of differentiation. Again, I'm going to take you back to a question in the textbook. So let's just go and we can check this question. Okay, and this is just to help you with stationary points. So if you look here, just want to go. Find the coordinate of the stationary points of the curve and determine the nature. No, they didn't ask the nature. So always what I do is I just differentiate. And then after I differentiate, I put it equal to 0. That's a very important point. And then I simplify the equations. And then I take the values and I put it in the original equation. So substitute in the original equation to get the stationary points. Okay, that's all I want you to first see. So let's go back to the question. Okay. So here is the question. So it's just a little bit more difficult, the differentiation, but not so difficult. So I just write down the formula. Now, just remember, if you differentiate, you don't work with underneath, you take it up. You don't work underneath roots, you take it to an exponent or an index. Okay, so in this case, just going to say 16x to the power negative 1. So what's the first thing I'm going to do is I'm just going to differentiate. So I'm going to say dy over dx. And if I differentiate, and again you can go to your formula sheet, but I think this is very easy. So if I multiply, I get negative 16 and I get x to the power of negative 2. Okay, and I'm bringing it, because if I have to do substitution, then I'm bringing it back. Okay, that minus looks like an equal. 16, and I'm just going to put it back there. Okay, now for the stationary points, so at stationary points, so at the stationary points, dy over dx is going to be 0. So I'm just going to put that equal to 0. So I'm going to say 2x minus 16 over x squared equals 0. And I take it over, so 2x equals 16 over x squared. And I multiply over cross. And if I'm getting, okay, let's just do that one first. So it's 2x to the power 3 is equal to 16. Okay, and here comes the thing. Very important. And I said it in previous questions. If you're going to take the cube root, don't say plus minus. It's an odd number. The reason is why a negative times a negative times a negative will be a negative, and a positive times will be a positive. It's just with even that you will go there. So please, if this is, and you can also get the negative. So if this is negative, the answer is negative. And if this is positive, the answer is positive. So I'm just going to take the cube root of 8, and that's just going to be 2. And then I substitute it in the original equation. And I'm just going to get, now I'm going to just substitute it in there. So now let's just say substitute. You don't have to write in original equation. And I'm just going to say y is equal, and it's going to be 2 squared plus 16 over 2, and that's going to be 4 plus 8, and that's going to be 12. So therefore the stationary point is going to be, and I write it first the 2, then the 12. Okay, and that's as easy as that. Okay, not very difficult. Let's look very basic differentiation. Find the equation of the normal to the curve at the point. Now again, I just want to refresh your memory. So let's just go back to where we will find this in the textbook. And we will find this in the textbook, okay. Okay, there we will find it. And that was, I hope I showed you the previous page also. That was page 269. Okay. In the previous page, it was page 285, if I didn't see it. Okay. So in this case, so let's just see the normal. I just work with this. Okay, but let me look at an example. I think it's always easier. So find the equation of the normal to the curve at the point. The first thing that you're going to see, now we have the x and the y coordinates to -2. So first you're going to differentiate the formula. That's very important. Then you're going to substitute that x value. Do you see? When x is, you substitute. Then you get that gradient. But if it's a normal, it's perpendicular. So that means I must take that, turn it around and change the sign. Okay, and that's basically what I did there. Okay, and that's why the formula is like this. So it's, if it's a normal, if it's a tangent, you don't do it. But if it's a normal, you take the reciprocal. And then you just substitute. There is the point. And what that is the point. So that's x1, y1. And you basically just substitute and you get your answer. Okay, so go back to page 269. Refresh your memory if you cannot recall that. But let's look at the question. Okay. Okay, now don't forget you already differentiated the equation. I'm just going to write it in another form. You can just check to see if you differentiated correctly, but I'm just going to write it like this. You see, because it's easier if you have to substitute. So my differentiated formula was 2x minus 16 over x squared. I'm just going to keep on working with this one. Now, if it's at this point, I take the x value, so to find the gradient, and I substitute the 4. And if I substitute the 4, I'm getting 8. Now, this is minus 16 over 16, so 1. So I'm getting 7. So if it's a normal, so normal, the gradient is going to be perpendicular. And that's going to be negative 1 over 7. Okay, but you can first write it in the formula also here. So now I'm just going to say the equation of the normal. I'm just going to go back to blue. So the equation of the normal, and that's going to be y minus y1, negative, that's the reciprocal, and x minus x1. And don't forget that your point is 4 and 20. I just want to show you. So this is going to be y, start with y. Where do you start with y? This is x1, this is y1. Just keep it in mind. So I'm going to say y, and in the place of y1, I put 20. Now I already took the reciprocal. Otherwise, you just say negative 1 over 7. That's why the formula say it like that. And then x minus 4. And basically just going to simplify now. So this is going to be y equals, now it's negative 1 over 7x plus 4 over 7. And then plus the 20. So you're going to get y is equal to negative 1 over 7. Oh, that 1 over 7 looks not nice. 1 over 7x. You can say plus 24 over 7. That's correct. Or if you want, you can take it and say, doesn't matter. You can leave it like that, really. But if you want to take it, I see it just in the memo. They also indicate that. Okay. I didn't show you the marks. Okay, maybe I can just quickly show you the marks of this question. So let's just go in red. You will get for this one, you will definitely get as soon as you differentiate. To find the coordinates of the stationary points, as soon as you differentiate it, I just want to make sure for the attempt to at least one correct term. So they said just the attempt. If they're correct, so they actually give you up to their 2 marks, which is nice, which I can understand. And then as soon as you find, you make it an equation, okay? And then you come to that point, okay? And in this one, you are going to get, for getting that -1/7, okay, or even if the formula there, putting it in that equation, okay, and then simplifying the equation which we did there, okay? And that's how you will get your marks. And that was question number 11. Let's look at question number 12, the final question. The function f is such that fx equals square root 2x plus 2 for x bigger than or equal to k, where k is a constant. Find the least possible value of k. Now, before I'm doing this is the domain. I want to take you back to a page in my old higher level book. And I'm loading it on this channel now, so if you want, you can look at it in the future again. Okay, so let's just check. I just want to see, there it is. That was in the old higher level book. Now, I think in this table, there is examples in the AS level book, but this table just help you a little bit also to understand. So, how to find the domain if you just have the formula, you don't have the sketch. Now, there's a few things. If it's underneath a root, like the example now, then it must just always be bigger than or equal to 0 because it cannot be negative. Okay, and then you will get your value of x or the domain. If it's like this, then you remember you cannot divide by 0. So this can just not be equal to 0. Okay, and if it's like this, now it's 2. You cannot get the negative square root, so it must be bigger than or equal, but you can also not get 0. So you sit with all that, both that options, and then notice that x is bigger, x is negative does not satisfy the inequality because it can only start there. So it starts there, but I must remember that it also excludes 4. So the only thing that I wanted you to see in this page is that remember roots cannot be negative. To remember you cannot divide by 0. So let's go back. Let's go back to the question. So basically this is just a root. So I can just start by saying, okay, I just know that that must be bigger or equal to, it can be 0, but it cannot be negative. So I just simplify this. And this is and then I get x is bigger and equal if I divide -1. Now just compare it. You have there x is bigger and equal to k. So basically, you see, you can equate it and basically say, okay, so k is equal to -1. So find the least possible, that's the least, because it must be bigger, but k, the least possible is -1. Okay, and that's how you do it, very easy. So I think again, a mark for just being and then coming to the final solution. Now, for the value of k found in part A, find the expression, now, okay, this is very important, especially for the last question. If they do this, that's indicating inverse. And if I come to the last, if they do this, this is differentiation. So this is functions, this is differentiation. So but we'll come to that. Now they are asking the inverse. Again, I want to take you to a page, just refreshing your memory, but it's coming also from ordinary level. So if you look, so let's just see, where can I take you now? I'm going to take you to this one. Okay. I want to see if this is, find the do. Oh, I just wanted to show you that in the AS level textbook, okay, it's not in a table, but I just wanted to show you for the previous one, I did it in question. It was on page 111. And can you see, you cannot divide by 0, so that's how you find that. And you can, it must be bigger or equal to 0. Okay, and that's how you find that one. So that question is relating to this one. I just wanted to show you that it's also taken up in the AS level book. Okay, but I'm finished with that one. I want you to now focus on this one. Okay, now it's clear. It was just a problem. I just had to close it and open it again. Okay, so if we look at this, it's just to refresh your memory. It's on page 108 in the AS-Level textbook. So it's basically just going to show you how to find the inverse. So just make it y, then make x y, and then make just y again the subject. So get rid of that and make it, and don't forget to end with this statement. It's just refreshing your memory on inverse. Okay, but let's just go back to the question paper. Okay, here it is. So I'll make it a little bit bigger. Find the value of k in part 8. Find the expression. So, okay, let's just start by writing the formula down. And I just put a y. Okay. And then don't forget that I'm just going to make this x and I'm going to make this y. And then I'm going to say, I'm just taking it over, so it's square. And then I make y the subject of the formula. And then I just divide 2. And I'm ending with f minus 1x. And it's just going to be x, let's just get x squared minus 2 over 2. I can leave it like that. You can also say x squared over 2 minus 1, but it's not missed. And just end by showing that it's the inverse function. Okay. So find the value for the value of k, okay, in part, find the expression and step. But remember, this is the value. Now, I actually want to show you, don't forget the picture. If you, and I'm first going to take you to the pictures. I first have to show you this. Okay, so let's just look at number B. Okay, I want to take you to this picture. Okay. Can you remember the graphs of inverse? Because according to the graph, which we're already going to start, if this is the function, it will be a reflection in the line y equals x. But what I more want you to know, say this is the point, I don't know what, but say this is going to be the point -1 and 0 on fx. Then this point, which is the reflection, it's going to swap around. So it's going to be, okay, let's just see, this was -1 and 0. So this is going to be 0 and, let's just see, I'm putting it incorrect. Sorry, my point is not correct. That's my point. Okay, now it's better. I want to say it's not working. So then this point is going to be 0, -1. So if it's a reflection, basically the x value is going to become y and the y value is going to become x. Now it's better. So with that in your mind, you go back to the question. Okay, so let's just find the question. Okay, so basically, when you were drawing that graph, now if you had a picture, that's going to be excellent. Otherwise, I just wanted to show you. So let's just get, so if this was, okay, now this was the x value. I will now show you the picture or start with the picture. Now they say, try to know the pictures, but if you really don't know the picture, a table always helps. So just to get a little bit of an idea. So let's just go. So if this is x and this is y, and I'm at fx now. So if this x value, because remember, x is bigger than or equal to -1. So if this is -1, what will be the y value? So basically, you just have to substitute it in there. So if you substitute in there, you have now, I don't want, okay, so y equals, and you're going to substitute in there 2, and you're going to substitute -1 plus 2, and that's going to be -2 plus 2, which is 0, it's fine, and it's 0. So that value is going to be 0. That is for fx. So if you come and you have now f minus 1x, okay, and remember, you don't have to explain this. You just have to come to the answer. I'm just helping you to understand it. So then, if this is going to be x, y, then this 2 is going to be swapped. So this is going to be 0, and this is going to be -1. So I can say, and I'll show you now in the graph, as soon as we have the graph, we'll come back to this question. So I'm just going to say the domain is x is bigger or equal to that 0. Okay, so that is just basically that one that, okay, let's say this range become this one's domain. Okay, and I think I showed it also, and I'll see now if I go back to the textbook where I showed it to you. Okay, so that was very important that you had to know that. Okay, so they ask you for the inverse and they ask you to state the domain. Now we go on to the next one. Okay, so for the value of k found in both, sketch the graph. Now it's very important. If you sketch the graph, you have to use a ruler. Okay, now I'm going to maybe struggle a little bit. Oh no, I think I'm going to succeed. I'm going to use my ruler here. Now you have at least, okay, that is, okay, let's just start again. Okay. Here's my ruler. Okay, let me see. I'm trying to use, I can put a ruler, but it's going to waste time. And so please don't make a rough sketch, then or a sketch that's not a little bit indicated. Then it's not, the shape is, it's going to affect the shape and you're not going to be correct. Okay. Okay, that's more or less. So I'm just going to say this is, say, -1, this is -2, this is 1, 2, this is going to be 1, this is going to be 2, this is going to be -1, this is going to be -2. Okay, I'm going to go back to my table. So if I continue this table for both of them, I can basically just work out 1. Do you agree? So if this is 0, and let's just go for 1. And so if I put 0 there, I'm going to have square root 2. And if I put 1, you agree, 1, so it's 2, plus 2 is in square root is going to be 2. Now, remember that this basically just swap around. So this is going to be square root 2 and 0 and 2 and 1. And now I'm basically just going to plot that values. Now, you can work this square root 2, you press it on your calculator. If you press it on square root 2 on your calculator, just to have an idea, to a decimal, so square root 2, it's going to be 1.4. So just keep in mind that this is, say, 1.4, but mark it like that. So let's go to the graph again. They say find the value of k, or for the sketch the graph on the die, label your graphs and indicate the intercept of each graph with the coordinate axis. Okay, so they want where 0 and 0, and we include it. But let's start with the first one. Okay, so if I'm going to start with the first one, or let's make that one green. So according to my, it's -1, okay. Now it's 1.4, so 1.4 is about, but say it's square root 2, but you can just on your calculator indicate. And then the other one was, and now I must just go back, previous, so it was 0 and negative, and it's 1 and 2. And it's 1 and 2, say 1 and 2. Okay, you can even go to, if you want to take it a bit further, you can go to 2. Let's see if we put 2 there. 2. And then it's going to be square root 6. And let's just see what is square root 6. So square root 6, it's like 2.4. So it's a bit bigger. So it's going to be 2.4. So let's see, so 2.4. Okay, doesn't matter. I just want to keep it to green. Okay, so it just was 2 and 2.4. Okay, my sketches. Okay, but it doesn't matter. It's just going to be like this, the shape. Do you see? It's always a bit more difficult to draw on this. Okay, I don't like that coming up. So this is going to be 2. I think that that one is too high. That's why I don't want to work, because it's 2 and 2.4. Okay, because I didn't go to 3, but let's just go a little bit closer. Okay. Now, don't forget that the line in the middle, and it's going to be here and here, and that is going to be, and it's going to be, say, here. And again, as I said, I prefer that you do this a little bit with a ruler, or most of it, so that you don't make unnecessary mistakes. Okay, so you can already, in my board makes it a bit more challenging for me. Okay, but it doesn't matter. Okay. So basically, now I just swap it around. So if I swap it around, I'm going to go to my table, and it's going to be -1. Okay, let's just go. It's going to be -1 and 0. Okay, let's just go back to, okay, so it's going to be negative, oh, this is previous page. It's going to be 0 and -1. That's better. So 0 and negative. That's better. You can see. Okay. And then go back to my previous page. It's going to be square root 2 and 0. So it was 1.4, 1.4, 1.4 and 0. So it's going to be approximately, so it's square root 2. And don't forget this is -1. And then it's going to be, go back to your previous, it's 2 and 1. It's going to be 2 and 1. And then if you want to go to, yes, 2 and 1. And let's just go back to the previous one. Then it's square root 6 and 2. So it's going to be 2.4 and 2. So it's going to be 2.4 and 2. Okay, so maybe that line is not so, but it's going to give me something like this. So if I look at the sketch, okay, so I don't know if this line is now accurate enough, but they want me, so it's basically like this, and it's basically just like this. And they want you to indicate that, and I don't know if they, but I think they will not penalize you if you just put the coordinate points. So 0 and put it 0 and -1 and 0. So that, and don't forget to label your sketches. This is fx and this is f minus 1x. Okay, and that's what you do. Okay, so label your graphs. So as I said, that helps. They will look at the shape, and then according to you, don't have to do that blue line. And now comes the last question. Very, very easy. But I think so many students made a mistake. They think this stands -1. It's not the inverse. It's differentiation. So take your formula, write it down. Okay, put y. No, yes. I want to keep it to fx. Put it like this. And then just put a half. Okay. This is the chain rule. This is differentiation. So I want to take you again to the textbook, and this is the last one I'm doing in the textbook. So if you look, the chain rule, and I'm going to do the long, it's not that you can do the short also. Can you remember? You make this one u, okay, we simplify u, and then we differentiate and we multiply it with each other, and we just take it back. And you could have found this, and this was a very complicated one, on page 264 in the AS level, y equals mx plus c textbook. Okay, but let's go back and do that final question. Okay, so I'm going to just, let's make it y. Yes, I think y will work. So I'm going to make it y, and then it's y. And I'm just going to, as I said, you can do this short, but I want to do it a little bit. I'll come back to this. And I make u is 2x plus 2. That is just the typical chain rule. So this is dy over du, and that's a half u, and if a half minus 2 over 2 is minus a half, and this is du over dx, and that is just 2. And then dy over dx is, if you multiply this 2, and that is going to be, you multiply u to the power of -1/2. And you can bring it then just down. So you bring it and you take it back to the root. So it's 2x, don't forget, that was u. Where is u? There is u, 2x plus 2. I just put it back into my root. And now, basically, now I will go, so basically, I can actually say that this is now the differentiated equation. And I can just go back and I can just substitute it back. And it's 2, and in the place it's 7 that they say, plus 2. And that's going to be 1 over, now I just 2 times 7, that's going to be 14 plus 2, and that's 1 over the square root of 16. And the final answer of this question paper is going to be 1/4. Okay, and now I'm just going to, yes, and that's how you do it. And if you want to see, oh, it's just 3 marks. So for the sketch, I just want to go back to the sketch, maybe to indicate, they said they will give for the shape, if it's the correct intercepts with the axis, no others. And then if you indicate shape over there, yes, the shape, the correct 2. So they give 2 marks for that and 2 marks for that. And then for this one, they will give it, if you come to this equation, let me just show you. If you come, so if you get this equation, there where I differentiated, where that's almost there, yes, I think so. They will give for this one, after I differentiated, and then they will give all correct, allow and simplified, and then they will give for the final answer. And that was question paper number 1 of the AS level 2021.